Hey there, everyone. This is 6.4. It's maximization and minimization with mixed problem constraints. So this is our last section of chapter 6. Basically, now we're going to turn our focus to having mixed problem constraints. So in 6.2, we did basically profit maximizing or maximization problems with constraints that were less than or equal to, where we introduced basically slack variables. And then in 6.3, we did minimization problems, but with constraints that are greater than or equal to, which means we can just make that into dual problems and solve it just like 6.2, which was the maximization problems. Now, we're going to turn our attention to basically mixed problem constraints, which means you could have less than or you could have greater than as some of the constraints. And we'll talk about introducing the big M method. And we'll also talk about how we introduce surplus variables and artificial variables now. So just to give us an example problem, suppose we have this maximize profit is equal to 2x sub 1 plus x sub 2, subject to x sub 1 plus x sub 2 less than or equal to 10. And negative x1 plus x2 is greater than or equal to 2. And x sub 1 and x sub 2 is greater than or equal to 0. So in this case, right, that first constraint of x sub 1 plus x sub 2 is less than or equal to 10 is basically, this one right here, right, is basically just going to be a slack variable. And that is exactly why we have x sub 1 plus x sub 2 plus s1 equals 10. Now, something to note, in the case where we have negative x sub 1 plus x sub 2 greater than or equal to 2, we need to introduce basically a surplus variable that we're going to subtract off. So the surplus variable is subtracting off from an inequality that has greater than or equal to in it. And then, again, the profit function is the same way we set it up that way. Now, if we were to go through and do the basic solution found by setting the non-basic variables, x1 and x2 equal to 0, right? So x1, x2 equals 0. Then we'd find that s1 equals 10 and s2, though, equals negative 2. Well, this can't happen because this means that we don't have a solution that is feasible. So in other words, this basic solution is not feasible since the surplus variable is negative. So because of that, we need to add in something called an artificial variable. The artificial variable, if you look at the bottom of the screen, you see now that surplus variable, that minus x2 plus a sub 1 is equal to 2. This is the introduction of basically an artificial variable so that we have x sub 1, x sub 2, the basically slack variable, the surplus variable, and the artificial variable all greater than or equal to 0. One of the other things that we have to do because we add this artificial variable in is we want to make sure that it penalizes the profit function. So we put it up here in the profit function where we subtract capital M times a sub 1. So again, M is just some large positive number, and a sub 1 is whatever the artificial value is. And obviously, in this case, if we were to make the artificial value really high, right, that'll impact our profit function up here, right? So that's why we have to penalize it. All right, so we now have a new problem, which we call the modified problem. And this is how we introduce the big M method. And now I'm not probably going to write up in that window screen much because it's really important for, I think, you just to follow along with the visuals of it for now. So again, we have our normal simplex tableau that we would have. We have our x sub 1, x sub 2, s sub 1, s sub 2, a sub 1, and our profit. And then finally write our right-hand side, or you might think of it as the numbers as I've written before. We just plug in our values, the coefficients in front of them. You'll notice that the first row would be 1, 1, 1, 0, 0, 0, because there is no S2 and no A1 and no profit in that first constraint. And in the second constraint, you'll notice that we have a negative 1, a positive 1, a 0 for S1, a negative for S2, a 1 in front of the A1, a 0 because there's no profit, and then 2 on the right-hand side. Now, another key distinction here is that when we go to that bottom row for that profit or the objective function, we'll have negative 2, negative 1, 0, 0, M, 1, and 0. So in this case, the M comes from basically negative M up here. And right now I'm wondering, why shouldn't it be negative M? Keep in mind, we take all of this stuff that's on the right-hand side, because they have variables, and we move them to the left-hand side by subtracting them over here. or in this case, adding MA to the other side, and that's how we get the positive M. Just like how we get the -2 here and -1 is by subtracting this over to the other side, right? So again, I'll write it on another piece of paper on the side here real quick, just to make sure that's clear. And I'll make this a little bit bigger. Oops, I clicked wrong. So in this case, if you have the profit is equal to 2x sub 1 plus x sub 2 minus MA 1, we need to move all that to the other side and then basically have it equal to 0, right? So that means we'd subtract the 2x1, we'd subtract the x2, and we'd add the MA1 to the other side. So if we do that, then that means we're going to have -2x1 minus x2 plus MA1 plus P equals 0. And that's how we get basically those coefficient values that you see in the bottom row. All right? Make that a little smaller. Move on. So we'll just make that small. So the initial simplex tableau, the definition of it basically is the requisite number of basic variables must be selected by the process described in section 6-2. Well, that's the same steps we were just doing. Basically, that is, a variable can be selected as a basic variable only if its corresponding column in the tableau has exactly one non-zero element. So for example, S1 here is considered a basic variable because it has zeros and 1 is the only number in that row. You'd also see that profit is the only other basic variable, okay? And has exactly 1, and the non-zero element in the column is not the same row as the non-zero element in the column of another basic variable. The remaining variables are then selected as non-basic variables set equal to 0. So that means x1 is 0, x2 is 0, and in this case, a1 should be set equal to 0. And that's how you find out that s2 is equal to -2. Oh, by the way, s2 is another basic variable. And s2 would be equal to -2, which we can't have. So that means this is not a basic feasible solution. So we need to do something else here. So the basic solution found by setting the non-basic variables equal to 0 is feasible. So we need to figure out how we can make that. So when we want to make that, what we need to do is we need to remove that m from underneath the artificial variable. So in other words, we need to get this m out from underneath the artificial variable. And in order, when we do that, that means we're going to do -m times row 2, which is this row right here, right? And then we're going to add it to row 3 because we want to get a 0 below it. So in other words, we want to get 1 and 0s above and below it. And when we do that, you'll see now that we have m's now in our bottom row. You'll see also we have -2m, we have m, -m minus 1, and m minus 2. Keep in mind that m is a very large positive number, okay? So when we talk about pivoting here, you're going to see there's only one column that we can pivot on. But before we go and do that, let's interpret now what our basic solution is. So in this case, x1 is 0, x2 is 0, s1 is 10, s2 is 0, right? And a1 is a basic variable now, the artificial variable. So a1 equals 2, and profit equals -2m, just as we see down here, right? All right, the big concept here is to make sure that you have your artificial variable in and your surplus variable, and then removing the m from underneath the artificial variable. Once you've done that, you can proceed just as we've done before with basically our simplex method. So we need to identify our pivot column. If you were to look at this bottom row, right, you would find that the only one negative is this column right here, because m, again, is a very large positive number, which means that -m would be a very large negative number, okay? So again, keep in mind one other note. If this had been a negative in front of this m, here you'd have -m minus 2, which is actually more negative than -m minus 1 if this had been a negative here. But this is our pivot column. Now we need to do basically the operations to figure out which row we pivot on. And so we do basically the ratio of the right-hand side, 10 divided by 1, and we see that it is 10. And then we do the ratio of 2 divided by 1, and we get 2. So that means this is going to be our pivot element, and we're going to pivot on that row. And so now what we need to do is get 0s above and 0s below. What's nice with this being a 1, we can just multiply this row by -1 and add it to the first row. By doing that, that's how we'll get the 0, and that's what this operation right here is telling us that we're doing. Now in the bottom row, we need to get rid of that negative m minus 1. So we should multiply this row by m plus 1. Just let that sink in, because it's really important, because you're going to basically be distributing this across to that variable, right? There's this 1. So you have 1 times m plus 1 times 1, which is 1, which will make this a 0 down here. And now basically we now have x2 is in the model, basically in our solution, and it is equal to 2. And we still have that slack variable in there, which is equal to 8, and our profit equals positive 2. Okay, and now if we look at our bottom row, we see we have a negative 3 and a negative 1, but negative 3 is a larger negative number, so we're going to pivot on that column. Then we look for the ratio, but in this case, because there's negative, that means we can only pivot on the 1, which is the positive. Now, suppose that had been a 0 or a negative, we can't go any further. There is no optimal solution. We would stop. But in this case, it's positive, so we can do it. So we'll pivot there. And in this case, it's nice because it's a 1, that's a negative 1, so we'll just multiply by, we'll just add those rows together, and that's how we get the 0 there. So by the way, x1 entered and x2 entered as well. And now we get a 0 down below. So we'll do 3 times that and add it to the bottom row. And now if you look, we have reached our optimal solution. In this case, x1 equals 4, x2 equals 6, and the profit equals 14. If you want, you could graph this and check to verify that that's true. Now, the procedure for the big M method, introducing slack, surplus, artificial variables to modify it to form the modified problem. So if we wanted to do that for this matched problem, right, repeat example 1 for basically the matched problem here. So first thing is, if any problem constraints have negative constants on the right-hand side, multiply both sides by -1, right? So this one right here, you multiply this by -1, which would flip that sign there, make that a positive, that's a negative, that's positive, and that's positive. And now it's greater than, which means we'll have to have a surplus variable and an artificial variable for it as well. In this case, what we can do with this equality is we can move the numbers to the other side or multiply by -1 on both sides. Either way will work. And then we're going to introduce the slack variables first, and we'll introduce the surplus variables and the artificial variables in each constraint. We'll introduce artificial variables in each equal constraint. And then for each artificial variable a sub I, add ma I to the objective function. So let's write this one out and show basically what the modified, or basically what the modified problem should look like. So that way we can set it up, okay? So I'll make this bigger here. Whoops. There we go. And I'll zoom in a little bit, so that way it's a little better. It's not really zooming in, but you know what I mean. All right. So this is the matched problem, number 1. So we're going to do that. And so we have the max profit is equal to 3x1 minus 2x2 plus x3. So I'd write these down. X sub 1 minus 2x sub 2 plus x sub 3 is greater than or equal to 5. I'm going to do a couple of changes right off the bat. So in this next one, we have the negative x1, negative 3x2 plus 4x3 less than or equal to -10. I'm going to multiply by -1 right off the bat. Get that -10 to become positive and flip that sign. So this will be x sub 1 plus 3x sub 2 minus 4x sub 3 is greater than or equal to 10. All right. Now the next one we have, we don't have to do any changes, so it'll be 2x sub 1 plus 4x sub 2 plus 5x sub 3 is less than or equal to 20. And now we have the bottom. And in this case, I'm going to negate everything and make it negative. So I'll have negative 3x sub 1 plus x sub 2 plus x sub 3 is equal to positive 15, right? Multiply both sides by -1, and then that flips the signs. All right. So now that I have that, also we'll have my non-negativity constraints. And now you can probably see why we write that as condensed form, because if we have a lot of variables, it's not going to make sense to write each individual x sub 1 greater than or equal to 0, x sub 2 greater than or equal to 0, x sub 3 greater than or equal to 0. We would just say x sub 1, x sub 2, and x sub 3 are all greater than or equal to 0, right? Okay. Now, let's form that modified problem, all right? So I'm going to grab another color here. See if that'll help. And let's do it to the right side over here. So move my keyboard over. So now we have that. So the first thing I want to do is introduce my slack variables first for constraints that have less than or equal to. That's this one right here. So I'll have 2x sub 1 plus 4x sub 2 plus 5x sub 3 plus S1 is equal to 20. Okay, so that'll be the first one I do. You might, if you start up here and do these other ones first, you might have different S sub 1s or A sub 1s, whatever you're doing. But we'll construct it all this way as well. Now, actually, let's change that. We'll make that S sub 3 for now, and you're wondering why. You'll see here in a second. So let's start up at the top. We have x sub 1 minus 2x sub 2 plus x sub 3. And in this case, I need to cut some of that surplus out. So I'm going to subtract s sub 1, but then I'm going to add an artificial variable. Hence why I want to use s sub 1 and a sub 1. That's why I'm going to relabel this to s3. And you'll see this is going to be s2 and a sub 2 as well. And so that's why. Equals 5. And then here we have x sub 1 plus 3x sub 2 minus 4x sub 3. Then I'm going to subtract off the surplus variable. And I have s sub 2 plus a sub 2 equals 10. All right. Now we need to go down and do our last one, which is basically step 4, introducing artificial variables in each constraint equal to, with each equals constraint, sorry. 3x sub 1 plus 4x sub 2, oops, not 4. X sub 2 plus x sub 3 plus a3 equals 15. Now, that means we're going to have x sub 1, comma, x sub 2, comma, x sub 3, comma, s sub 1, s sub 2, s sub 3, a sub 1, a sub 2, a sub 3, all greater than or equal to 0. Right, and you're like running out of room. So there's that. And now we need to readjust that profit function. So let's just write out first as a profit it normally would be. So we'll have 3x sub 1 minus 2x sub 2 plus x sub 3. Now, for every artificial variable we've added, we now need to subtract that from the profit function, right? So a sub 1 minus m a sub 2 minus m a sub 3. That's basically what our profit function would be. This is our modified problem now, okay? Now we need to take that and put it in the Tableau. So let's go and do that and make sure they're all on the same page for that. So feel free to pause the video, rewrite all this down if you haven't already, or if you haven't been following along. I'm gonna need more space. So I need 5 lines. Wow, that's a lot. All right, so I'm gonna write it over here so you guys know. So I'll have x sub 1, x sub 2, x sub 3. We will have s sub 1, a sub 1, s sub 2, a sub 2, and s sub 3, a sub 3, profit, and finally the numbers, or as you might think, the right-hand side, okay? And now we'll just go in and plug those equations that we have up here in the green into here, all right? So we should have 1, negative 2, 1, negative 1, 1, 0, 0, 0, 0, 0, and 5. Should be what we have. And we should have 1, 3, negative 4, 0, 0, negative 1, 1, 0, 0, 0, and 10. And then here we'll have 2, 4, 5, 0, 0, 0, 0, 1, 0, 0, and 20. And here we'll have we should have 3. Oh, yeah, negative 3, 1, 1, 0, 0, 0, 0, 0, 1, and 0, and finally 15. Sorry, there was a slight typo. That should be negative 1 there, negative 3x1. Sorry, that's why I paused there for a moment. And then we'll have our bottom line. We're basically going to put in our profit function. And so that means we're going to go to this piece right over here. We got to move everything to the right-hand side, right? So that means this becomes negative, positive, negative, positive, 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 right? Pause that for 1 second, repeat. Move this to the other side, it becomes negative. Move this to the other side, it becomes positive 2. Move this to the other side, it becomes negative 1. Move this to the other side, it becomes positive m. And this becomes positive m, okay? And then it equals 0. So let's go through and fill all those out. So negative 3, positive 2, negative 1, 0, positive m, 0, positive m, 0, positive m, 1, and 0. Okay, couldn't see that the whole time, but there you go. That's what it should look like. Now, we could go through and solve this all out, but I think we'll pause there and we'll tackle a couple other problems. Basically, what you need to do now is get a basic feasible solution. So that means we need to remove the m's from underneath the artificial variables so that we can have a basic feasible solution. Because if you're going to go and solve this one out, s sub 1 would equal negative 5. And therefore, that is not part of our original constraints where basically s sub 1 must be greater than or equal to 0. So, all right. So again, I'm going to make this small up here. So for the preliminary simplex tableau for the modified problem, we use row operations to eliminate m's in the bottom row, right? I'll put this right here. That's exactly what I'm saying, right? We got to get rid of this m's in the bottom row. So I'll remove those out. The resulting tableau will be the initial simplex tableau, and that basically will give us a basic feasible solution. And then step 3, we'll solve the modified problem by applying the simplex method to the initial simplex tableau found in step 2. And step 4, basically relate the optimal solution to the modified problem to the original problem, right? If the modified problem has no optimal solution, then the original problem has no optimal solution. If all the artificial variables are 0 in the optimal solution to the modified problem, then delete the artificial variables to find the optimal solution. If any artificial variables are non-zero in the optimal solution to the modified problem, then the original problem has no optimal solution. So these are 3 cases you need to make sure you're familiar with when you get a solution finally, okay, in the step 4. Now, let's talk about how we set up these problems. And I'm gonna pause, and why don't you see if you can set up, well, here, we'll do match problem 2 together, one more, okay? We'll do one more together to make sure we're on the same page. I'm not gonna rewrite the problem out, but I'm going to rewrite the modified part out, okay? So if we do the modified part, okay, I'm not going to write the profit out yet, okay? So I'm going to hold off on writing profit. I will write P equals, so that way you know that I'm working on, there we go. And so we're going to do a max of the profit equal to, and we'll go through that one, and then subject to the following constraints. So we got to make sure that we get those right. In this first one, I have x sub 2 plus x sub 3 is greater than or equal to 4. But the modified of that would be, we'd introduce a slack variable because it's a less than or equal to symbol. So plus S1 is equal to 4, okay? Now the next one we have is x sub 1 minus x sub 3 equals 6. Well, this requires an artificial variable. So we'd have x sub 1 minus x sub 3 plus A1 equals 6. And then this next one we have x sub 1 minus x sub 2 minus x sub 3 is greater than or equal to 1. And if we do this one, we're going to have a surplus variable because we need to knock that down, and then we need to add that artificial variable in. So in other words, x sub 1 minus x sub 2 minus x sub 3 minus S2 plus, that looks like a 5, but it's an S, plus A2 equals 1. All right, now what we need to do is we need to go back and reconstruct our profit. So in our profit, we'll still have the 3x sub 1. Oh, sorry, I read the bottom profit, match problem 3. This is match problem number 2, just to make sure you guys are all on the same page. So we have x sub 1 plus 4, x sub 2 plus 2x sub 3. Now we need to subtract off MA1 because we added one artificial variable in. We also added another one here, so we need to subtract off MA2. All right. So if we go and construct our table below here, we're going to have basically x sub 1, x sub 2, x sub 3. We'll have an S1, an A1, an S2, an A2, a profit, and finally numbers or right-hand side. So disregard this as make this a straight line, and we'll make that line across. And you're right, running out of room a little bit, move just a little bit. And there we go. So let's fill in all those details. So we have 0 actually, because there's no x1 in that first one. Then we have 1, 1, 1, 0, 0, 0, 0, and 4. And then we'll have 1, 0, negative 1, 0, 1, 0, 0, 0, and 6. And then down here we'll have 1, negative 1, negative 1, 0, 0, 1, but it's negative, and 1 and 0, and finally 1. And then we got to put in that profit. So putting in that profit, we'll have a negative 1, because right, we got to move these to the other side, move these to the other side, move these to the other side, move these to the other side. So basically you just negate those and you can put them down there. So negative 4, negative 2, 0, positive m, 0, positive m, 1, and 0. And then that is basically, now we need to get the m's out from underneath the artificial variables. So that's what we need to do to start. Once we started that, then we can, and we have those out from underneath the artificial variables, and we have a basic startable solution, then we can go through the steps that we need. So. All right. Let's go through and actually follow those along, all right? So I'm gonna rip this off. So I'll put this up here, it's gonna get to the very top. So the first thing I wanna do is I'm gonna pick A1. So I'm gonna get rid of A1 out from underneath there. So I'm gonna do negative M times R2 plus R4 is gonna be the new row 4, okay? That's gonna be the first thing I wanna do. So I'm not changing anything else. So I'm just gonna recopy this down, which may take me a moment here. Let's go down one more line so that way I can write in the x sub 1, x sub 2, x sub 3. And the numbers on the right-hand side, just like we had before. Nothing changes in the top rows. So here, let's just do the bottom. Let's just do that second row because nothing changed in that, just to highlight which rows we're actually working with, okay? All right, and then I want to change that bottom row, okay? So I'm going to multiply by negative m times row 2, this row, and then add it to that fourth row right here, okay? So negative m times 1 is negative m. Negative m minus 1, okay? 0 times anything is still 0, and then minus 4, right? And then negative m times negative 1 actually is positive m, minus 2, all right? And then 0 times anything is still 0. 1 times m is, 1 times negative m is negative m, plus m is 0. That was the whole point of why I did that, right? So I got that artificial variable now is going to be entering here, and I'll see you in a second. And then S2 is 0, and 0, and 0, and negative m is negative 6m, okay? Got it? All right, let's just recopy everything in just to show this, all right? 1, 1, 1, 0, 0, 0, 0, and 4, and 1, negative 1, negative 1, 0, 0, negative 1, 1, 0, and 1. You should do this slowly. I'm only doing it fast to try to make sure I don't have the video so slow, okay? But you should make sure that you slowly copy things down. This is where it's really important to make sure that you are consistent about your negative signs and don't lose them or drop them. All right, so is this a basic feasible solution? The answer is no, because we still have, whoops. We still have an m under A2. 0 times anything plus m is m, okay? Ooh, that was an error. So that m is still there, and this should be a 1. Jeez. Sorry about that. That was a bunch of mistakes. This should be an m, and that'll be a 1, okay? Because negative m times 0 plus m is still m. 0 times negative m is still plus 1 is still 1, okay? Sorry about that. Now we need to get rid of that m from underneath this artificial variable. So I would want to do negative m times row 3 plus row 4, okay? Becomes the new row 4. Negative m times R3 plus R4 becomes the new row 4. Sorry, that's sloppy over there, but I'll rewrite it out. I'll have x1, x2, x3, s1, and I'll move this out of the way now. A1, S2, A2, P, and R numbers are the right-hand side. All right, so basically that row doesn't change, right? None of the rows above change, so let's just rewrite them all out. Just trying to highlight what we're doing here. And now we need to do that negative m times this row 3 and add it to that 4th row. So negative m times row 3 plus row 4 becomes the new row 4. Okay? So negative m times 1 plus a negative m, negative m minus becomes negative 2m minus 1, right? Negative m times negative 1 gives me positive m. So I have m, oops, no, plus a negative 4, we'll say, because I wrote in pen. Negative m times negative 1 is positive m, so you get 2m minus 2. 0 times negative m is still 0, plus 0 is still 0. 0 times negative m is still 0, plus 0 is 0. Negative m times negative 1 is positive m, plus 0 is m. Negative m plus m is 0. All right, good. That artificial variable is gone. Good. 0 times negative m is still 0, plus 1 is 1. Negative m plus a negative 6m is negative 7m. Okay. Now, is this a basic feasible solution? Right? Is this a basic feasible solution? So let's check. So x1 equals 0, right? x2 equals 0. They're non-basic because they're not singled out, right? x3 equals 0. S1 is a basic variable because it has zeros in its column and only has one non-zero element, and that equals 4. Is A1 a non-basic or basic? It is a basic because it equals 6. S2 is now a non-basic, which equals 0. And A2 is equal to 1. And the profit equals negative 7m. So in this case, x sub 1, x sub 2, x sub 3, S1, A1, S2, A2 are all greater than or equal to 0, which means we have a basic feasible solution. So now we can start our pivot operations. And so we'd find the most negative number in the bottom row. Looks like it's negative 2m minus 1. So this would be our pivot column. And we'd go and pivot there, find the ratios. It looks like this would be our pivot element. And then we'd go through the same steps we've been doing before. And that's pretty tedious. So we'll go through and do that here in a second. I'm gonna pause the video, my battery is low. Okay, so that's how we do that one, all right? So let's move on to, by the way, if you want a check digit for this problem, if you go through and solve it, which I would recommend, the max profit should equal 22, and x sub 1 should equal 6, and x sub 2 should equal 4, and x sub 3 should equal 0. So if you want to go check that out, I would go through and check those out, all right? Go through and do that. If I do that, it's going to be a really long video. So match problem, I'm going to leave alone. You can follow the example that's in the text. I think it's really important, though, to set up example 4. So you can think of basically a minimization problem and how we talk about how do we make this a maximization problem, or how we can think of how do we solve this problem. So here, I'm going to make this small. All right, so minimization by the big M method. basically, in addition to solving any maximization problem, the Big M method can be used to solve minimization problems. How is that? Well, basically, what we'll end up doing is taking the profit function or the cost function, we'll negate it, and we'll call that the profit function. So what you're basically doing is taking the function and inverting it over the x-axis, if you think about it in just two-dimensional space. And then you find basically the point maximizing value, but it's actually going to be the minimizing value for your function. It's pretty cool how we can use that. So let's set up example 4, because I think this is important to understand how do we do that. So production scheduling minimization problem. A small jewelry manufacturer hires a highly skilled gem cutter to work at least 6 hours per day. On the other hand, the polishing facilities can be used for at most 10 hours per day. The company specializes in 3 kinds of semi-precious gemstones, J, K, and L. Relevant cutting, polishing, and cost requirements are listed in the table below. How many gemstones of each type should be processed each day to minimize the cost of finishing stones? What is the minimum cost? So the first thing we need to do when we do these kind of problems is figure out which is our decision variables. So here, we'll go move this up, draw my line there, call this example 4. So in example 4, we need to figure out what are our decision variables. So decision variables. So in this case, x sub 1 is going to be the number of type J gemstones processed each day. All right. X sub 2 is going to be the number of type K gemstones processed each day. All right. And X sub 3 is going to be the number of type L gemstones processed each day. All right. So now we have our decision variables. Now all we need to do is basically construct our constraints, right? So let's do our subject to constraints, okay? In this case, we have basically the cutting constraint, which means x sub 1 plus x sub 2 plus x sub, oops, that's a plus x sub 3 is going to be greater than 6 hours, right? If you're reading this back, it says a small jewelry manufacturer hires a highly skilled gem cutter to work at least. At least means at minimum 6 hours, if not more. So 6 hours per day, okay? So that's the first constraint that we have, is basically that cutting constraint. Now the polishing one, we're gonna have 2x sub 1 plus x sub 2 plus 2x sub 3. And now here's what we need to figure out. This says at most 10 hours per day. So we can't work more than 10 hours a day. All right? Or 10 hours or less, I should say, right? At most 10 hours. They can work up to 10 hours. All right, now the next thing we need to do is figure out what our cost function is. So our cost function is gonna be 30x sub 1 plus 30x sub 2 plus 10x sub 3, right? The cost, again, is cost per stone right down here. So we have that. Now, when we do minimization problems like this, we can take the cost function. If we call it negative C, that actually equals a profit function. So that means we'd go and negate each one of these. And then we'd go and solve this, just like we normally would. So let's talk about how we put this in the table, in the tableau, okay? I'm gonna rip the page off here in a second. And, all right. So I'll lower this down right here so you guys can see that. And I'll write down we're gonna do the modified problem. So in the modified problem, we have mixed constraints. We have a greater than and a less than. I'm gonna switch those up. Well, no, I'll just leave it the way it is actually. So I'll first tackle the first one. I have x sub 1 plus x sub 2 plus x sub 3. And then I'm subtracting, because I wanna bring that down, basically a surplus variable, S1, and I'm gonna add that artificial variable in. And then I'm gonna have this other constraint, which is gonna use a slack variable, plus S2 equals 10. Oh, yeah, this equals 6. You guys need that though. All right, now the next thing I need to do is I have my profit equals negative 30x sub 1 minus 30x sub 2 minus 10x sub 3. And in this case, I'm going to subtract off MA1. And now I have my modified problem, and I can go through the same exact steps I've done previously. So again, I would put this into the simplex tableau. So we'll go through and do that together. All right, so you have that. Sorry, I'll level it out. Hopefully, probably neck's getting crinked. There we go. And we have 1, 1, 1, negative 1, 1, 0, 0, and 6. And down here we'll have 2, 1, 2, 0, 0, 1, and 0 and 10 finally. And then we'll have 30, positive 30, because we got to move those over the other side, right? So that means it becomes positive 30. I'm skipping this step, but I think you guys can do this step on your own. But again, that would just basically mean you take the equation and you write this as positive 30x sub 1, positive 30x sub 2, plus positive 10x3 plus MA1 plus the profit equals 0, right? I ran out of room. That's basically what you're doing is you're just moving all this to the left-hand side, okay? So 30, 10, 0, M, 0, 1, and 0. And now here again, we need to get that M out from underneath that artificial variable. So let's do this together. I will solve this one out, and then this will be the last example of this section. There is one more problem in my slideshow, but try to keep things short and simple. We'll do that. All right, so I need to move that M from out from underneath here, so I'll do negative M, R1 plus R3 becomes the new row 3, and you can't see that, and now you can, okay? So move that out from underneath it. So that means I'm going to take that because I want to get a zeros above and below the artificial variable. So that way I can start with a basic feasible solution, okay? Now, negative M times 1 plus 30 gives me, all right, so before we do that, let's recopy our tableau down. S1, A1, S2, P, and the numbers or right-hand side. Again, I intermix those mostly so you guys are comfortable with. If you go on the internet and look for other solutions, you'll see something along those lines. Sometimes people will write number, they might write right-hand side, RHS, or RS even. So we'll have a negative M plus 30. So everything up here stayed the same, all right? So I'm gonna write that all in, keep my life a little simpler. All right, and now I'll have a negative M plus 30. And then I'll have a negative M plus 10, and then a negative M, which becomes positive M underneath the S1. And you'll notice sometimes it's better to write a little more space when you're dealing with the M method because you're gonna get really crowded down here. This becomes 0 because that was the whole point, negative M plus M. 0 times M is still 0, plus 0 is still 0. 0 times M is still 0, plus 1 is 1. And negative M times 6 is negative 6M plus 0. All right, so now we have that set up. And now we're ready to proceed. Now, keep in mind, we are trying to find the most negative number in this bottom row down here, right? Okay, and we never pivot over here. We always pivot on that side of it, okay? Stop shaking. All right, keep hitting the camera. That's why it does that. All right, so that means this column right here, because think about it. Negative M is still the same value both ways, but plus 30 would actually bring it more towards the positive side, whereas plus 10 only brings it slightly more to the positive side. So that's actually our pivot column. And now we need to do the ratio. So 6 divided by 1 and 10 divided by 2. Well, obviously that's 5 and this is 6. So that means I'm going to pivot there. So we need to make that a 1 and then make zeros above and below it, okay? All right, so let's go and do that. So I'm going to divide this row by a half. So I'll do 1/2 R2, which you can't see, becomes the new row 2 star, all right? So 1, 1/2, 1, 0, 0, 1/2, 0, and 5. All right. You guys okay if well, you guys don't have a response, but we'll just write them in. I was gonna say, are you guys okay if I don't write the variable terms up here? But let's just do it out of good practice and habit. All right, and that means I need to get a 0 above, so I'll do negative R2 star, because it's the new row 2, plus row 1. So -1 plus 1 is 0. -1/2 plus 1 is +1/2. Oops, yeah, -1/2, sorry. Plus 1 is +1/2. -1 plus 1 is 0. That's the whole point of why I did that. Use 0 plus a -1 is still -1. 0 is -0 is 0. Plus 1 is still 1. -1/2, -1/2, 0. -5 plus 6 is 1, right? And now we need to get that m plus 10 out from underneath there. So how do we do that? Well, in that case, we need to do basically we'll have to have basically a positive m and a -10. You see why? We'll have to have -10. So times row 2 star plus row 3. So think about it this way. 1 times m minus 10 plus -m plus 10. Does that make that go to 0? Yes, it does. That was the whole point of why I want to do that, right? So just to make sure that that's clear. So if we do this one, we'll have basically, so I'm going to do each individual of these because this is a little more complex. So I'll have m minus 10 plus -m plus 30. What does that give you? That's right. Yes, good. I heard you guys from a long ways away. Positive 20. Now if we do the next one here, we'll have negative, well, it's basically the same. Well, actually, we have a half now. So we have a half times m minus 10 plus a -m plus 30, right? So we have a half m minus 5 plus a -m plus 30. So this becomes a -1/2 m plus 25, right? Oh boy. So that's this one right here. So we have a -1/2 m plus 25. Comes that value there. And now 0 times anything is still 0, plus m is still m. 0 times anything is still 0, plus 0 is still 0. And a half times m minus 10 plus 0 is going to be 1/2 m minus 5, right? And then profit still stays 0. And then I have this 5. So we have basically this 5 times m minus 10 plus a -6m. So we have 5m minus 50 plus a -6m. Well, this will become positive. This will become -m minus 50. Does that make sense? Okay, are we done? No, because we still have a negative value right here. So we're going to pivot on this column here now. All right, so now we needed the ratio of 1 divided by 1/2, which is just 2, and then 1 divided by, 5 divided by 1/2, which is 10. So that means we're going to pivot on that one right there. And so what we want to do is maybe multiply that whole row by 2. And again, I'm going to have to use another piece of paper. All right. Oh, come on now. All right, so now we should have that. And so we're going to pivot on there. So I'll do 2 times row 1, 2 times row 1. Try not to lose that. And that'll become my new row 1 star, all right? So I'll have 0, 1, 0, -2, 2, -1, 0, and 2. All right, I'm gonna draw my lines in. And in this case, this would be x sub 1, x sub 2, x sub 3, s sub 1, a sub 1, s sub 2, p, and finally the numbers on the right-hand side. All right, I'm trying to keep that 1 in view still. All right, and now I need to get rid of that half below and then a -1/2 m plus 25 in the bottom row. So I'll do -1/2 times row 1 star plus row 2. All right, so -1/2 times 0, still 0, plus 1 is 1. -1/2 times 1 is -1/2 plus 1/2 is 0. 0 times negative a half. By the way, I'm adding up to here. 0 plus 1 is 1. Negative a half times negative 2 is negative 1. Plus 0 is negative 1. Negative a half times 2 is negative 1. Plus 0 is negative 1. Let's go back a second. Negative a half times negative 2 becomes positive 1, right? Sorry. S2, we have negative 1 times negative a half is positive a half, plus a half gives me 1. 0 times anything is still 0, plus 0 is 0. Negative a half times 2 is negative 1, plus 5 is 4. Now, let's go through and get that bottom row cleaned out. And so I need to get rid of the negative a half m plus 25, okay? So in that case, which you can't see, right? Move that, oh boy. I need to get rid of that bottom row, that negative a half plus 25. I need to get, oh. So if I just did 1/2 m times row 1 plus row 3, shouldn't that do it? Yeah, that should do it. So in other words, that'll give me 25, oops, sorry, won't give me 25. Oops, easy. We need to actually get rid of that half there, so I'll do 1/2 m minus 25 times row 1. And again, this is where if you want to double check this, you might want to do smaller steps here. But again, for getting this to be 0, because that's our whole goal, we want that to be a 0, we'll have 1/2 m minus 25 times 1, which is row 1, plus the negative a half m plus 25, which is the row 3. And do they cancel out to 0? Yes, 1/2 m plus a negative half m, that's 0. Negative 25 plus 25, 0, okay? Now we need to do each of these individual pieces. What's nice is that's 0. 0 here. So anything times 0 is still 0, and this will be 20. And x sub 3, 0 times anything is still 0, plus the 0 we originally had up here. Oh, you guys still see? Sorry, there was an alert that came on my phone that paused that. So we got that'll be still 0 there. And then we have a negative 2 times basically this 1/2 m minus 25. So 1/2. All right. All right. So we need to do this one right here. So we have negative a half m minus 25 times a negative 2 plus whatever's in that bottom row below S1 is m. So we'll have a negative m, and then this becomes a positive 50 plus m, which just results in 50. All right, good. And now this next one right here, we'll have a 1/2. We'll have 1/2 m minus 25 times 2 plus 0. Well, that's going to be m plus a negative 50, right? Or in other words, m minus 50. And then S2 will have a negative 1/2 m plus 25 plus a 1/2 m minus 5. So if we add those together, m's go away, and we're left with positive 20, and the profit still stays the same. Now here's the part that's really important. We have 2 times 1/2 m minus 25 plus a negative m minus 50. Okay, that's positive m, and that's a minus 50 plus a negative m minus 50. So that means a negative 100 is your final solution there. And now if we look at our answer here, what we have, so if we think about this, we have no more negative in the bottom row, so we're good, right? We don't pivot on that last column. X1 equals 0 because it's a non-basic variable. I'm gonna write them all down. X2 though is basic, and it equals 2. X3 is also basic and it equals 4. And S1 is also non-basic and it equals 0. And A1 is also non-basic and equals 0. And S2 is also non-basic and equals 0. And the profit equals negative 100. So this is what you get if you were to put them all out like this, right? But keep in mind, this was originally a cost minimizing function, which means we want to minimize C, which is equal to the negative of the max of profit. So in this case, we do negative of negative 100, which actually ends up being positive 100. So that is our minimizing cost of positive 100 with X1 equals 0, X2 equal 2, and X3 equal 4. Pretty cool. So that's it. I'm sorry if that was really long. Big M method is long, but it's really important that you get a handle on it. Feel free to see me during virtual office hours to ask questions. All right. So